Variable acceleration in one dimension. When acceleration is variable, we may be able to express the acceleration as a function of time. If this is the case, it follows that the velocity and displacement are also functions of time. It should be clear that velocity is the rate of change of displacement. Therefore, v is ds dt. You should know this just from driving around in a car, that the faster you go, the more distance you travel in a particular amount of time. So velocity is the rate of change of your displacement. It should also be clear that acceleration is the rate of change of velocity, and therefore A is dv dt. We can encapsulate this in the diagram that follows. So if we have displacement, velocity and acceleration, remember when working with vectors, we'll probably call this r. So to go from displacement down to acceleration, we need to differentiate the displacement and then differentiate the velocity. So working our way across the diagram this way, we differentiate. Since integration is the reverse process, it makes sense that to go from acceleration across to displacement, you'll integrate.